We have another examples. First, we're supposed to use the property for the logarithm of product and convert this log of product to the sum of two logarithms. So I'm going to have natural log of 5 plus natural log of t. For the second term with the logarithm, I'm going to use the property for the log of power. I'm going to convert this exponent to the coefficient and simply write 2 natural log of t. Why I did that? Because I have already natural log of t and natural log of t. I have two like terms. I have equal left side to 8.5. Next, I'm going to move my ln5 to the right side because this is nothing else, just the number. I have unknown over here. Natural log of t plus 2 natural log of t is 3 natural log of t. This is equal 8.5 minus ln 5. In order to find natural log of t by itself, I have to divide both sides equation by 3. 3 and 3 cancels out. So if ln t equals 8.5 minus natural log of 5 over 3. In order to find value of t, I'm going to convert the logarithmic form to the exponential. Please keep in mind that there is invisible base e. I'm going to rewrite this as e to the power 8.5 minus natural log of 5 over 3. Remember, if you enter this exponent into the calculator, you're supposed to write or type the parentheses in the correct places. Otherwise, your answer is going to be wrong. This is equal t. So t is equal 9.9429. This is the solution to my problem. If you want to verify your answer, you're supposed to simply replace these two t's by this value, but don't forget to square, okay, for the second logarithm. And you're supposed to get the value on the left side equal approximately 8.5. Let's take a look at the second example. For the first logarithm, I'm going to use the property for the log of power, and I'm going to bring this 5 to the front of the logarithm. I have 5 natural log of a minus 4 ln a equals 1.45. 5 minus 4 is equal 1. That's why I'm going to have simply ln a equals 1.45. In order to find value of a, keep in mind that we have invisible base e and convert the logarithmic form to the exponential. I have e to power 1.45 equals a. So a is going to be equal 4.2631. Of course, you have to plug these two values into the calculator, right? And you're supposed to get this answer. If you want to verify your answer, simply plug in this value instead of a in the original equation. You are going to have natural log of 4.2631 to the 5th power minus 4 natural log of 4.2631 is equal 1.45. 1.45. So you can say that 1.45 is equal 1.45. That's why this is correct answer for this problem.